Alright, so chapter 6 preparation quiz part 2, moving on to continuous distributions. Let's get started. So, x follows a continuous uniform distribution between 13 and 35. Answer the questions below. What is the probability that x is less than 25? So, what that is asking for is f of 25, big F of 25, probability that it's less than 25, and I give you this formula right here. It's not in purple, there's no purple backdrop, but you know, probably the most important formula for this uniform distribution. So I'm going to copy this, and in this case we know what A and B are. Remember that A, which it's given to you in this formula, what A and B are. A is the minimum bound that x can be, so in this case it's 13, and B is the maximum, so it's 35. I guess let's start out putting that here and here. Oh, 13 and 35. And now it's asking for what's the probability that f of 25, you know, anything less than 25. So let's just start plugging and chugging in here. First we can change the A and B. We know that A is 13, B is 35. Let's not forget that parenthesis. And for this question we are interested in f of 25. So we just take out the x and put in a 25 instead, and you know, plug and chug away. So this is equal to and I could just type it in, but I think what I'm going to do in this case is put my x in right here and then have the f of x, big F of x. Put this guy in bold. So in this case it's 25 and big F of x we can solve for now. In this case we're interested in 25. It is parentheses x minus a divided by parentheses b minus a. There we go. And let's set this guy equal to that. So probability that x is greater than 25. Well, we know the probability that x is less than 25. The probability that it's going to be greater than 25 is the rest of the probability. So we can say that, you know, this is going to be equal to 1 minus 0.5454. And that's, you know, the key to finding out the easiest way to restructure one of these probability problems for cumulative distribution is to change the probability functions to be in terms of less than equal to. So in terms of big F. And if we do that in this case, we start out with this guy right here. And probability that x is going to be greater than 25. Well, start with the law of total probability. 1 equals, you know, put this guy in. So probability that x will be greater than 25, then say, oh, what's the converse of that? What's everything else? Probability that x will be less than equal to 25. Now, and, you know, this part, probability that x is less than or equal to anything, is the same thing as big F of 25. So, you know, now we subtract, you know, f of 25 from both sides. So, minus f of 25 on this side, minus f of 25 on this side. You know, there's our formula right here for the probability that x will be greater than 25. We just turned it in terms of big F, and that makes it easiest to solve. So, and that's exactly what we did here, 1 minus big F of 25. Alright, so moving on. Probability that x is less than 15. Well, same formula. Our a and b are the same, so we have this starting point again. And now all we want to do is plug in 13 in for x instead of 25. So we can do that right here. Just copy and paste because the process is the same. Change x to 13. That looks like 0 because we're interested in 15, not 13. And there we go. And let's look at this final probability function again. It is x right here minus our a divided by b minus a. So that looks right. Just plug and chug. Now, what is the probability that x is between 15 and 25? And like I mentioned earlier, the easiest way to do any kind of probability distribution, figure out any kind of probability for cumulative or continuous probability functions is to change it all in terms of big F. So we start out understanding that this is what we're looking for. Alright, but this is going to be equal to the probability that x is less than 25 minus the probability that x is less than 15. So basically, if you have, you know, here's our bounds, 13 and 35 right here, and we want to know the probability between 15 and 25. So we're interested in this probability, just to kind of show it to you a little visually. And a graph would be better, but it's hard to do graphs so easily in Excel. If you have difficulty with understanding this equation, just kind of gloss over it for now, and you'll see this happen more in the standard normal distribution. When we work more with that, I have graphs ready for us to use in those instances, and you can pick up, if you understand the standard normal, you'll be able to go back and get this easily. So anyways, the probability that x is between 15 and 25, we're interested in this probability right here. The bounds are 13 and 35, and basically what this equation is saying is if we take the probability of everything less than 25, boom, right there, and then we subtract the probability of everything that's less than 15, right there, then the remaining probability is probability that x is between 15 and 25. So, you know, here's the equation, and in general terms, it's probability that, you know, between a, if that x is between a and b, equals the probability that x is less than b minus the probability that x is less than a. And so if it's continuous, what you'll see, and I'll also demonstrate this in the standard normal, but this is synonymous with greater than or equal to. Alright, that's the same thing. So at the end of the day, what you have is this formula is exactly the same as this formula, and it's what we're doing right here. In this case, it's f of 25 minus f of 15. Let's move that over here. But you might be like, oh, Zachariah, we're interested in, probably the x is less than equal to, less than 25, not, and this represents s less than equal to 25. Well, those are actually the same. Why? I think we agree that the probability that x is less than equal to 25 equals the probability that x is less than 25 plus the probability that x is equal to 25. Alright? We agree on that? YouTube video, so yes. And continuous distribution, like I talked about in class, the probability that x is going to be any one number, such as probability that x is going to be 25, is equal to 0. We'll put it down here for demonstration purposes. And so, we can see that this left-hand side represents f of 25, and that's equal to the probability that x is less than 25, as well as less than equal to 25. So, this is how we are coming up with that caveat. Anyway, so let's just plug this in and solve for it. This equals f of 25, this guy, minus big F of 15, this guy. And looks like we forgot to put our f of 15 in there. Now we're good to go. So, easy peasy. And we'll see much more of this kind of work when we move down to the standard normal. So, what is the probability that x is equal to 15? Once again, that is meant to throw you off. It's asking for a little f of 15, like I just set up there. It's equal to 0. But why? Sorry to jump into this again, but one more quick explanation. X in this case is bound between 13 and 35. Okay, right here. So we're interested in all the values between 13 and 35. That's all the possible values for x. But so the total number of possible values for x is really infinite, because if you think about it, x could be 13.1, it could be 13.11, could be 13.111, it could be 13.111111111, and it just continues on forever, because it's continuous. So in reality, the number of possibilities between 13 and 35 are infinite. And if you are trying to the probability of any one value out of an infinite number of values would be 0.0000000000000 and onward, and maybe a 1 at the end, but that's actually equal to 0 as you take the limit of those zeros to infinity, because there's an infinite number. It goes to 0. So that's why for any continuous distribution, f of not just f of 15, which is the original problem, but f of x is also equal to 0, little f, because it's the probability that x is going to be equal to 15 in this example, 0. Expected value of x. That goes back to the properties which are given to you for the uniform distribution. We know it's just a formula right there. So we have our a and our b and our x. And x is not in this formula. It has nothing to do with the expected value. So just plug it in. A plus b divided by 2. Variance of x. Same thing right here. It's a property. This formula is distinct. It's unique only to the continuous uniform distribution. Alright, so it is going to be equal to b minus a. Square it, divide by 12. And you gotta be careful with order of operations. If you want, you can, put parentheses around here. You technically don't have to. Same answer. Alright, so standard normal distribution. As I mentioned in class, the standard normal distribution is simply one example of a normal distribution where the mean is 0 and the variance is 1. So there's a lot of different possibilities you can have for a normal distribution, table or graph or function. But what's distinct about the standard normal is that the mean is 0 and the variance is 1. So we're starting out sticking to standard normal, and the z here, z's represent standard normal. So probability that z is less than 0 is the probability that a standard, what's the probability that if z follows a standard normal distribution, that z will be less than 0. And to figure that out, the way that you solve for a normal distribution is step 1, you draw the distribution. And I have this Excel worksheet right here to help us draw or to visualize, because I can't draw it on pen and paper doing this kind of YouTube video. But you want to be able to draw it. I have this workbook, so you can use it. You can look at it and stuff, but it's for visual purposes. On the quiz, you're not going to have this workbook, so you're going to have to draw it and figure things out using the table and understanding what you're looking for. So let's start out. I have the z-score right here, and in this case, the z-score represents what the probability that the standard normal is going to be less than the z-score. In this case, the z-score is 0. You can represent the z-score with a little z. Okay, but in this problem, the z-score is 0. So getting to the money, first thing you want to do for a normal distribution is draw the graph. So y-axis is your f of x, x-axis in this case is your z-score. Now, anytime you have normal distribution, the center right here, draw the bell curve. The center of the bell curve is the mean. In this case, it's 0. Technical glitch. This is not 0. This is -6 times 10 to the -14th power. Don't worry about it. It's supposed to be 0. You get the point. That's close enough. So we draw our graph, and we're interested in what's probability that z is going to be less than 0. Well, find z less than 0. Find z as 0 right here, and then shade the section that we're interested in. So I'm going to do that on Excel. Right there, I can put z in for 0, and now this is the probability that we're interested in. Now remember, probability is the area under the curve for probability distribution graph. So, and cumulative. So we're interested in the shaded region. We want to know what is the probability that z, or the z-score, be less than 0. And we can see from here, 0 is the mean. Anytime you have a normal distribution, the probability that the mean is the median. That's a property of the normal distribution. So the probability that any normal variable, in this case z, is going to be less than its mean is always 50%. You know, the probability that's going to be greater than the mean is also 50%. The mean is what divides it. There's 50% on each side. So, beating a dead horse. We know that this is 50%, and the probability that it's greater than is also 50%. And, you know, this is to point out that the probability that z being less than 0 is the same as the probability of z being less than equal to 0. You know, in a continuous distribution function, the less than or the less than equal to, you know, they're equivalent. Why? Probability, we would agree that the probability of z being less than equal to 0 is equal to the probability that z is less than 0 plus the probability that z is equal to 0, correct? And, oops, forgot my plus sign. There we go. Butchered that. Now, in a continuous distribution function, we already talked about above, you know, the probability of z or anything on any variable in a continuous distribution being a specific thing is 0. This is synonymous with f of 0. Is the same as 0 itself. So we can see that the probability of z being less than equal to 0 is equal to the probability that z is less than 0. Okay, so that's why these two are the same. Looking at this one for a second time, we understand why, looking at the graph, it's that the probability of z being greater than 0, that's the white area now, the white area in the curve, is 50%. You know, it's a normal distribution. But the process, most of the time it's not going to be the mean. You're not going to find the mean right here, so it's not going to be a straight even 50. You're not going to be able to look at the graph and say, oh, that's 50%. So the process to figuring that out is change whatever probability you're looking for to be in terms of less than equal to. Why? Well, it's because this standard normal table only shows, you know, these percentages, these values represents the area to the left of the z-score. So it's only, using the table, you can only find the probability of it being left to a certain value. And so you got to get whatever probability you're looking for in terms of less than equal to. So that's what we do here. The probability of z being greater than 0 is equal to 1 minus the probability that z is less than equal to 0. Makes sense? And then we can find the probability that z is less than equal to 0 on the table. That's the process. So we find, where is z0 on this table? Well, here's our z's right here, z, and we're looking for z 0.00. That's the z we're looking for. So that's represented by this number right here. Oh, we know that the probability of z being less than 0.00 is 0.5. So this represents 0.5. We looked that up in the table, and you know, that's how we can get the 0.5. 1 minus 0.5. This is lit up yellow because I'm still in the process of creating this workbook. So you know, I think the majority of these are going to go yellow from now on. Don't worry about it. Nothing to do with these video solutions. Alright, so same thing. Next row, probability that z is less than -1. Draw your z distribution. like starting this out with -5, just because then it looks like nothing's shaded. Start out drawing your bell curve. This is standard normal, so make your mean 0. Now say, oh, I'm interested in probability that z will be less than -1. So find -1 right here and shade everything to the left of that. Shade everything we're interested in. There we go. And there, that's what we're looking for. And go to our table, find -1 right there, -1.00, that's this guy, 0.15866. That's what the table shows, and if we can double check by cheating, looking at this, 15.87, 0.1586. I'm willing to bet it's 6. Yep, there we go. Not a problem. There we go. So, moving on. Probability that z is greater than -1. Well, what's the probability that z is going to be greater than -1? It's going to be 1 minus the probability that z is less than or equal to -1. 1 minus. And you know what you should do in this case, you should do the same thing. You should start out drawing the z-graph. Your mean right here is 0, and then shading what you're interested in. In this case, it's everything that's white. So how do you look at that picture? You want everything under the graph that's white. How do you come up with that? Well, take the total probability, total area under the z distribution, that's 1, and subtract all the area, or all the probability that's left of -1. So we have this total area right here, subtract the shaded area, and then we just have the white probability that z will be greater than -1. So 1 minus probability that z will be less than -1. That's exactly what it is. 1 minus probability that z is less than -1. Here we go. Now probability that z is less than -1.05. So have your graph. Draw the graph, put in the mean as the center as 0, and then shade everything 1.05 into the left. There. This is the probability that we're interested in. Let's look that up in the table. -1.0 right here, -1.00, -1.01, -1.02, -1.03, blah blah blah, -1.05. This guy. 1486. 1486. 1486. That's the probability. It's given to you in the table. Probability that z is greater than 1.05. Just like right here. This is actually incorrect. There we go. That is going to be equal to 1 minus, well, the probability that z will be less than 1.05. So let's look at our table. Let's look at our z graph. 1.05. We draw the curve. We put 0 as the mean. Now we shade everything we're interested in. In this case, we'd be shading the white area. Everything greater than 1.05. And how do you get to that using the table? You have to take the total area in the curve, 1 minus everything to the left of 1.05. Okay, so we have to find the probability that z is less than 1.05. Go to our table, find 1.05 right there. Here's 1. 1.0, move it over right here. Probability that z is less than 1.05. That's 85314. 85314. So I'm going to put that right here. 85314. That's the probability that z is less than 1.05. Or this is same thing as f, big F of 1.05. This is equal to 1 minus big F right there. $14.686, and I'm guessing, I bet I forgot this one. I missed the middle one. Let's look that up again. Gotta be careful on these tables. Negative 1.05. Negative 1 right there. 0.0. Sheesh. Sorry. Negative 1.05. Yep, there was a 6 in there. 14.686. Hopefully you caught that. Man, look at that. These two probabilities are equal. Why? Why? Well, let's look at the graph. The second probability, we're interested in this tail. The first probability, we are interested in this tail. This is symmetrical. Symmetrical about the mean. So I will switch to this tab to kind of show you. In each case, both these tails, assuming this line's at negative 1.05 and this line's at 1.05, both these tails have the same area. So if I ask you, what's the probability that z is greater than 1.05, you can instantly know, oh, that's the same thing as z equals less than negative 1.05. You don't have to find this tail if you don't want to. Instead, just find this tail. Alright? So this is equal to z is less than negative 1.05. And that's why these two probabilities are equal. So, moving on down here. Probability that z is greater than 1.05 and negative 1.05 and less than 1.05. Back to this table. That means we're interested in this middle region right here. That's what we're looking for. And what that's going to be equal to, it's going to be equal to the probability that z is less than 1.05, which would be all of this probability, everything to the left of this line right here, minus this tail, which is the probability that z is less than negative 1.05. So, we look at this, and we draw it. That's the key, drawing it. That way you can figure this out. Draw your distribution, zeros in the middle, shade everything that you're interested in. That would be this middle section, and say, oh, if I'm, I can only on the table only shows everything to the left of these x numbers or z numbers. To the left of, and this shaded region is going to be equal to everything to the left of 1.05 minus everything to the left of negative 1.05 right there, and that's what's left over is the shaded region. So we can put that in our answers. Everything that's less than negative 1.05, which is going to be right here, minus everything to the left of negative 1.05. There we go. So let me repeat that because I kind of stumbled up. It is going to be everything to the left of 1.05, probability that z is less than 1.05, that's this guy, minus the probability that z is less than negative 1.05. That's this white tail we want to exclude. And that would be this guy. There's a second way to do this, and that's to realize that these two tails are equal, and what's in this middle section is just going to be 1 minus the probability of these two tails. I mean, that's effectively what we did here. So all you have to do is calculate, and since these two tails are equal, all you have to do is find the probability of one of these tails and take 1 minus 2 times the probability of this left-hand tail. So that's the best way of doing it. 1 minus 2, because there's two tails, each tail has the same probability right there. There's your correct answer. Now, probability that z is less than negative 1.05, or the probability that z is greater than 1.05. What are we looking at? Well, draw it first. Here it is. Oh, everything, we're interested in everything that's less than 1.05. That's this guy, this white tail, or anything that's greater than 1.05. Well, it's symmetric. Everything, this tail is equal to that tail. So, these two tails together is just going to be whatever the probability of this tail is, multiplied by 2. And why do I choose to find the probability of this tail and not the probability of this tail? Well, that's because in our normal distribution table, we only find the probabilities left of a certain number. So we want to find this white tail. We can find that. We have to look up negative 1.05 in this z table, and then that'll tell us this probability. So, we did this, but let's just do it again. Negative 1.05. Oh, 0.1486. That's the probability of this tail right here. I'm interested in both the tails. So what's 2 times 0.14686? Here's the probability of the left-hand tail. We just take this times 2. And obviously the two tails is the probability of the two tails is the probability of the middle region. If you add these up, it's going to be 1. There you go. So, alright, let's fly through these last ones here. Probability that z is in between 1.54 and negative 0.45. Draw the graph, which I did right here. Draw the bell curve, means 0. Shade the area we're interested in between, just say this is everything right here. This line is negative 0.45 and this line's 1.54. We want everything in between here. So how do we get up? How do we come up with that? Well, it's going to be the probability of z being less than 1.54, everything right here, the blue and the left white tail. And then we're going to subtract the white tail from it. So probability that z is less than 1.154 minus probability that z is less than 0.45, or negative 0.45, excuse me. And, we can express that in big F. Go back to our other workbook. Control Tab actually switches it automatically. And it's just like, oh, okay. This is going to equal the probability that z is less than 1.54 minus negative 0.045. So what's the probability that z is less than 1.54? Look it up in our table. Find 1.54 right here. That represents the probability of everything to the left of that. 0.93822. 93822. Now find the probability of z being less than negative 0.045. Find that in our table. 0.045. This is everything to the left, negative 0.045. 0.32636. 0.32636. And there we go. You know, subtract this guy from that guy. There we go. Same thing right here. It's gonna be equal to. I'm not gonna draw the graph this time. I got it figured out. Everything less than 0.89. 0.89. 0.89 looks like this guy. 0.81327. 0.81327 minus everything to the left of negative 1.15. 1.15. Looks like that guy. 12,507. There we go. Alright.